Now, what happens, excuse me, if we replace y equals x squared by y equals negative 3x squared? Well, let's do some graphs. Now, here's the y equals x squared graph. I put that one in blue this time just because that's a piece of chalk I had in my hand. But to distinguish it from the graph that we're going to construct of negative 3x squared. And constructing negative 3x squared is really quite easy if you just remember the order of operations. Some people mess that up. I think they got the idea. Okay, so we take their usual x values. Why not? At least a good, we can at least start that way, and if that doesn't work out, we can shift them or whatever. But it's not necessary. We take our x values, and then we plug each one into this expression, okay? Looking for the word. Okay, so if x is negative 2, x squared is 4. You multiply that by negative 3, you get negative 12. I want to emphasize that you don't get negative 3 times negative 2 quantity squared. You're not squaring negative 3x, you're squaring x. And then you have a multiplication by negative 3. Order of operations. You exponentiate before you multiply. This is a multiplication between the negative 3 and the x. You got to square x first. Okay, so I think everybody understands that. Some people were a little careless, and it's easy to do. No prejudice. Okay, now, so we do that, and we get the graph of y equals negative 3x squared. Construct your own. I'm not going to explain how this was constructed. It's obvious. There are the points. That's the curve we get when we draw the smooth curve through our points. Now, two things about this graph. Okay, it's inverted. It's reflected through the x-axis, in other words, and it's a lot skinnier. It's stretched in the vertical direction. Okay, well, why is it inverted? Not hard to understand that. A minus sign here is going to make all the signs negative, whereas they were positive here. So if you've got a function with positive and negative values and put a minus anything in front of it, that's going to make all the negative values positive and all the positive values negative. If in addition that number is something besides 1, negative 1, it's going to stretch the graph. It's going to make all the y values bigger, and what does making a y value bigger do? I'm looking at this graph, there's something that looks really wrong here, but I'm not going to worry about it. Construct your own. There's a flaw in this graph. These points here should be somewhere else. Okay. In any case, again, the negative sign takes all the positives and makes them negative. Since all the y values are positive here, they all become negative. And the 3 means we're multiplying the y values by 3, so all our y values move the points 3 times as far from the x-axis because all the y coordinates are 3 times as big. So it stretches the graph and inverts it. Okay? So we conjecture that y equals a times f of x has the effect of moving each point a times as far from the x-axis. And if a is less than 0, it also reflects the graph through the x-axis. And I'll add one thing here. This is a vertical stretch by factor. Actually, it should be the absolute value of a, but you think a. Okay? So if a is negative, it does invert the graph. So a is negative 3, but it still moves the points 3 times as far. It doesn't move them negative 3 times as far. That's why I use the absolute value here. You can think about that, but I think you have the idea. So we're not going to worry too much about it. Okay? Now, I did something down here, but that was late. Okay? Now let's look at another thing you can do to the x squared function. You can take y equals x squared and add 4. So y equals x squared plus 4. What's that going to do to the graph? Can you think what's going to happen to your y values? They're all going to become 4 greater, which means everything's going to go up 4 units higher. That's what's going to happen. But let's check it out and make sure that what I said is correct. Taking the usual x values, omitting the 1/2 and -1/2, we get 8, 5, 4, 5, 8 y values that correspond to x equals -2, -1, 0, 1, 2. Well, that's going to give us the white graph here. If that's 0, 4, that's 1, 5, well, I'm doing 1, 5, and 2, 8 on this side. And on the left, I've got -1, 5, and -2, 8. The x squared graph, of course, is down here. And again, construct these graphs and convince yourself that what I say is happening is actually happening. But we can see that every point of this graph lies 4 units higher than every point of this graph. Now, we can't really see the 4 units on this small graph. As I say, construct your own graph and convince yourself that this point here moves up 4 units to this point. This point moves up 4 units to this point. This point does the same, and this point does the same. Okay? So that every point down here moves up 4 units, so we just kind of draw little segments of length 4 from the points of this graph, as long as they're vertical, and then connect those points to get our transformed graph. This transformation, where we add a number to our function, is called a vertical shift. It shifts everything vertically by whatever number we put in here. And if it was a -4, the vertical shift would be -4. Every point would go down 4 units. So I say y equals f of x plus 4 vertically shifts the y equals f of x graph 4 units. That's all there is to it. And those are the 3 main types of transformations. Now, your book talks about another type, reflections, but we see how that works because of the negative sign. And then it also has horizontal compressions that I don't want to talk about right now because they're not important. They're not necessary for any of the graphs that we've talked about so far. So I'm not going to introduce horizontal compression right now. When we need it, we'll introduce it. But you really don't need it until you start getting into your exponential and sine and cosine functions. And we'll get into exponential functions. We'll talk about it then. Okay. But right now we're dealing with power functions. We're only dealing with functions in general, but we're about to deal with linear functions and quadratic functions and power functions, and then rational functions and stuff before we get to exponential functions. So I'm just going to talk about these 3 transformations. And what you get then is the general rule that y equals f of x minus h shifts everything in the h units in the x direction. If we multiply our function by a, that vertically stretches the function and perhaps reflects it. And if we add k, that moves our graph k units in the vertical direction. If k is positive, it moves it up. If k is negative, it moves it down. So we say that this function vertically stretches the f of x function, whatever the f of x function is, by factor a, vertical stretch by factor a. And again, if a is negative, it inverts things. Horizontally shifts the graph h units, vertically shifts the graph k units. Okay, well, if f of x equals x squared, then what is a f of x minus h plus k? Can you do that? Well, f of x minus h, if f of x equals x squared, replacing x by x minus h, we're going to get x minus h squared, right? Now, a and k, we don't know the values, so we can't really do anything about that, so that a f of x minus h plus k is obtained just by substituting x minus h for x in your f of x definition. So you get a times x minus h squared plus k. Okay? Now, you should be able to answer the same question for each basic function, for the 1 over x, the 1 over x squared, x cubed, and e to the x, or 2 to the x, I'm sorry. Okay, well, here it is for 2 to the x. if f of x is 2 to the x, what is the expression a times f of x minus h plus k? What is this new function? This function that takes the points of this function, moves them all a times as far from the x-axis, and switches them over on the other side of the x-axis if it happens to be negative. And then shifts the graph h units in the vertical direction, whether h is positive or negative. It moves it that far in the horizontal direction, not the vertical, and then moves the graph up or down according to whether k is positive or negative. Okay, that's what this function does. Well, if f of x is 2 to the x, then a f of x minus h plus k is a times f of x minus h. F of x minus h, x has been replaced by x minus h, so you replace x by x minus h. Where's x? It's the exponent of the 2, so it goes here as the exponent of the 2. Now people were doing 2 minus h, and they were doing 2 to the x and then minus h without the h being anywhere near the numerator, the exponent, okay? The idea is simply that whatever x is replaced by here goes here, and that's what you get. So make sure you understand that visually and conceptually. And then we just have our plus k. So the AF of x minus h plus k is just this. Okay. Then again, we know that this function, whatever the number for a, the number for k, and the number for h is, accomplishes the corresponding vertical stretch, horizontal shift, and vertical shift.